so thank you. We would have sat here trying to draw it. So
Okay.
just 3x-intercepts. Oh my God.
So, looking at part D, is that a possible graph for this function? DJ's like, yes, Nathan, you're saying no, why not? Oh, you said it is possible?
Oh, yes.
Yes?
Yeah.
Yeah? You sure?
How did you? I think you have 4 x-intercepts and your relative maximum is 3.
Okay, and so we want to notice, right, there is a multiplicity of what here? 2. But how many actual x-intercepts do I have? Remember, there's a difference between the x-intercepts and the roots. When I say 4 x-intercepts, I mean 4 different x-intercepts, right? 4 real distinct x-intercepts. So remember, this is what we actually looked at, those possibilities the other day on, or yesterday literally, on page M1-239. Remember how we drew it out and we talked about how there's real distinct roots, so 239 if you look there. There's that difference between the multiplicity of an x-intercept versus the actual number of x-intercepts. And so this would only be 3 distinct x-intercepts or roots. One of those would be a multiplicity of 2. I don't think any of y'all drew it like this, did you?
No.
No, because we need it to be
4 x-intercepts.
4 x-intercepts. Could that be a possibility now?
Yes.
Does that make sense? Okay, so then a lot of us very quickly looked at E and we're like, yo, that's dumb, like, that's not possible. And then they started freaking out because like, how am I supposed to graph that? Well, you're not, right? So why is this impossible?
There's a degree.
You have a degree 2, but you have 3 x-intercepts, that doesn't work, or 3 roots. So the challenge that I gave group 1, because they got here a little bit quicker than everybody else, was actually write an equation for this. Did y'all come up with a possible equation? What you got? What do y'all think? Would that be a possible equation based on these first 2 details?
Oh, no, wait, degree 2. Is that degree 2?
Well, that's what I'm saying, just based on these first 2.
Oh, no, then yeah.
So a negative a, remember that root of negative 2, so the x minus negative 2, so an x plus 2, right? Then x minus 2, x minus 5. So we can very clearly see how many factors are there, linear factors. 3. So is that possible to have a degree 2? No. And so what we would say is impossible. 3 x-intercepts requires at least degree 3. Does anyone know why I say it has to be at least a degree 3? It could be more, right? Notice there's the possibility that it could be x minus 2 squared, right? And then it would just touch the x-axis and then go away. Could be x minus 5 cubed, right? We could have extra multiplicity, but we'd still only have 3 x-intercepts. Something like this may look like, what would that be? Be 5. Okay, so but it has to have that x-intercept, has to have that x-intercept, and it's going to go through there, so that would look something like this. And so what I'm trying to get us to see here is how to sketch based on different details that we know. So why in the world did it have this squiggle through here? Please don't draw this or anything, but why would it have this squiggle? Why wouldn't it just go straight through? always have to find out why?
It's cute.
It's cubed, right? See how that x minus 5 is being cubed? So it would have to have a multiplicity of 3, which remember a cube kind of flattens out through that x-intercept. And so x minus 5 cubed would have that flattening out effect. That's what we want to recognize there. Notice how it's a negative a value, so I had to start in quadrant 2 and end in quadrant 4, right? It had to be actually a reflection like this one. And so those are different ideas that we want to notice, right? So this would be 3 roots, 1 more, and 1 more, so a total of 5 roots, which is how I was able to figure this stuff out. Again, remember, if it's a 5th degree polynomial, how many extrema could it have?
4.
It can have 4, 1 less, right? Does this have 4? It's only got 2. So remember, the most it can have is 4, but it could have less.
But it had 3 and 18.
Say that one more time?
It got 3 18.
Yes. What's your question? So remember, it has 3 x-intercepts, but it still has 5 roots because that's a multiplicity of 3.
How you gonna got 5 roots? Listen, I'm too hard.
This has a multiplicity of 3. Remember, a root is different than an x-intercept. You can have multiplicities with the roots. But like, it would only be 3 distinct x-intercepts. So we would have an x-intercept of x equals negative 2 here. We would have an x-intercept of x equals 2 there.
Oh, I see.
But then I would have an x-intercept of x equals 5.
3 times.
But in terms of roots, that would be a multiplicity of 3.
Yeah, okay. Oh, you supposed to.
Okay, So-
There's like 3 D's on here, so it's like.
but notice, so I point out, well, that's not
Yeah,
this.
no, I don't even know what that is. Everybody else told me they don't even have it.
It's an understanding check.
Oh.
They do have it, but it wasn't homework. It's on here. If you look, it says lesson 4 forms of quadratic functions. So lesson 4 forms of quadratic functions, or quadratic equations, part B, and you flip it over, and there's part D.
Yeah, I know.
So you have to look under the different
Yeah,
lessons.
the other page though, like, there's some stuff that we're supposed to do.
All right,
Do anything on this one.
I can sit down and show you in a little bit. So let's really quickly talk about this. Describe what each characteristic of the graph tells you about the polynomial function. What does the end behavior automatically tell you? And so you can actually reference what's over there. When we have certain end behaviors, we already know a couple of key details about the function. If it's even or odd, right?
Okay, what did we?
So if the polynomial is even degree, if the polynomial is even degree, is it always up
Or down.
or down? Mostly the end behavior is the,
Shape.
Wait, if it's even, yeah, they're together.
so the end behavior goes in the same
Oh, same
direction.
direction.
Yeah. If the polynomial is even degree, the end behavior is in the same direction. Yeah, this is the talk is the end of the lesson, at the end of 3.4. The end behavior is in the same direction.
That's definitely wrong. What page is it? Okay, so,
One line, 243.
I was just,
Oh, this homework page, that's why.
Yeah, you probably already tore it
Yeah,
out, because
it's
it's one of the
terrible.
homework pages.
is it this one?
No, it's the page before that, yeah.
I think I already turned that in for homework. Did I? Is that one?
You didn't do it either.
I think it was.
I hope not.
Was it?
I mean, it is, there was homework associated with it, but you shouldn't have turned it in yet.
Well, I turned them in bulk. I turned you like 6 pages in at once because my grade is like down because of homework, so I was like,
Trying to get on top
yeah,
of it.
exactly.
We're supposed to do only one?
You were supposed to do 2 and 3.
Okay, just check.
Oh,
I don't see it in here.
what do you call that thing?
Call what thing?
Thing. Folder
A
holder?
sorted binder,
It's an expandable file folder.
an expandable file folder.
Yeah.
I don't know if it's like an old people thing, but my grandma calls her wallet a billfold.
That is one people.
Like I've never.
Gracie, here you go. So, right here.
Oh, there's one stack.
As they say.
Wait, no, I don't want them back.
But you need to look through what you need for right now, and then we'll go back over it. So if the polynomial is even degree, the end behavior is in the same direction. If the polynomial is odd degree, the end behavior is what?
It's in the opposite
There we
direction.
go.
I just realized I can figure it out now.
Yep. And so that is an easy way to notice that. And remember, another part of it is what I have up there. With an even degree, if A is positive, the end behavior is going what? Up. And if it's negative, the end behavior is down. And then there's the odd is a little bit tougher, but
Not really, they're going in different directions, you just like
Right.
that direction.
you just have to figure out which one is going down, which one's going up. Right?
That's my problem is I
But
always
don't you look at
assume
the top?
started there.
Don't you look at the sides, because the negative is on the negative side going up, and then the positive on the positive side.
It's however you want to remember it. Like personally, I know my just y equals x cubed really well, so I know if it's a negative x cubed, it's flipped, it's a reflection. Okay. So what does the x-intercepts tell us about?
Oh, the degree of the function?
Okay, so the x-intercepts tell us about, I don't know how I made that. All right, yes, it tells us about the degree, but there's something else. Because do you see every root in the x-intercepts? No. And remember, can you have a multiplicity in there? Okay, so the x-intercepts tell us, I would say, the minimum degree.
Like what it stops it on the X or something?
On the x-axis.
The minimum degree. Right? And the reason why I again say the minimum is like if I have something like this, well, how many x-intercepts do I have?
1, 2.
2. But is this a quadratic function? It's got 2
But
x-intercepts.
it's gonna be an even behavior. Right?
It is going to be even degree.
It's not quadratic.
Why do you know it's not quadratic? Remember, quadratic is a parabola. Is that a parabola?
Yeah, it's a parabola. Well, you said that same thing about the other equation, but you said it's still like it's going up, they're both coming up.
It's going to have the same end behavior as an even degree.
Well, no, it's not.
Oh, I think I get it. So basically, even though they're both gonna keep going, it's telling us the minimum of like.
But look right here. Does a parabola have this?
No.
No, I don't have that.
So I must have what kind of roots that I can't see?
Imaginary.
Right. So I have 2 x-intercepts, so it's a minimum degree of 2, but if I look here, then I know there's got to be at least 2 more roots. So this has to be at least a 4th degree.
They're not touching it. Just touching it. Right?
Say it one more time, KJ.
They're imaginary.
They're imaginary.
So if you said
Remember, this coordinate system only has the real number system. So it has to have imaginary roots for it to come up like this. Also remember, how many extrema do I currently have?
One.
I have 3.
Or the increase in people.
Well, there's also that. How many? Okay, so that's 1 decrease, 1 increase, 1 decrease, 1 increase. That's a total of 4 intervals of increase and decrease, right?
It's like the.
So it has to be at least
So we
4th
know
degree.
we know it's a quintic or whatever,
4th is quartic.
or quartic,
Yeah.
yeah. And clearly, if it touches the line twice, we know that like kind of like on the sheet we did. Like if there's 2, that means there has to be like 2 somewhere floating in there.
Right.
So if you were to ask us like on this graph, like how many roots do you think there are? Would we say 2 real, 2 imaginary?
Correct.
Okay.
Does that make sense?
Real, okay.
So it's 2 x-intercepts, so that's 2 real roots.
It's true
But because there's this extra extrema in here, I know there's gotta be two imaginary, because remember, the maximum number of extrema is one less than the degree. So to have 3 extrema, I have to at least have a 4th degree. Does that make sense? And again, it doesn't look like a parabola, it looks like there's multiple little parabolas in there. So it can't be a quadratic.
Is there anything in like the equation for the thing to show us that, if that makes sense? Like if you give us like a random equation and you're like, match it to the graph or something, like, what does the equation look like?
Say that one more time.
Like if you give us an equation and a bunch of graphs, what do the equation, like you know how last time if A was negative, then we knew that was negative and we knew.
It's actually
you know.
part of your homework with the next part of the talk to talk, or talk the talk. So let's look at that. I think that's what you're asking. Okay, so what did we just talk about with the extrema? The extrema is always 1 less than the degree. So
Is that the relative?
the extrema, remember our extreme point, so it'd be relative, maximum, and minimum. So extreme points, max and min. Okay, so the and this is what we just talked about, the maximum number of extrema is always 1 less, let's just write out the 1 so it doesn't get confused, 1 less than the degree. And so again, that is not guaranteed that the number of extrema is 1 less than the degree, it's just the maximum number is 1 less than the degree.
Can you have more extrema than the degree number?
No. You can't even have the same number of extrema as the degree number. And to understand why, you get into some calculus concepts, but yeah, the number of extrema, the maximum is always 1 less. So
That's weird. There shouldn't be multiple, because like, if you have a little hump, and then you have a big hump, and then boom, and you're like, oh, extrema, like, that's, the top one is the bigger one though. So it should have been like the head.
well, what you're thinking about is absolute. The number of absolute extrema is actually only 1 ever.
Yeah, that's what I'm saying.
But that's absolute. What we're talking about here is relative.
Okay.
B, can't you have the same extrema and, degree? Like the same amount of numbers?
No, the extreme is always 1 less. So like,
But don't you have the same?
hold on. I'll go ahead and tell you, the degree of this polynomial matches, actually let's go a little bit further than this. The number of extrema in this case, or the number of, the degree, that's the word I'm looking for. The degree matches the number of x-intercepts. What's the degree of this polynomial? Right, 1, 2, 3, 4, and 5. So 5th degree. What's the number of extrema?
4.
Oh, 4.
Right,
It's always one.
the maximum number of, and again, but notice that's the maximum number of extrema is always 1 less. Okay, now in this case right here, we know it's an odd because opposing in behavior, right? 1, 2, 3, and there's actually 3 imaginary roots. No.
Do you count the imaginary roots with it?
Say that one more time.
Do you count the imaginary roots with the,
Well, once you know
Well,
what
the
degree
imaginary,
it is.
you count the imaginary roots because the number of roots always matches the degree.
Yeah, well, so once you know the degree, then once you see you only have like 3 x-intercepts, you know that there has to be 2 more somewhere.
Well,
Like,
depending
if it
on how
was
it's
a
kind
five,
of,
yeah,
right,
I was
right,
just-
right,
I was
right,
just
right.
acting like it's
So
a-
this is actually a 5th degree right here,
Mhm.
okay? Because it's a 5th degree, what is the maximum number of extremas?
4.
4. Then how many extrema are there actually? 2.
Yeah, so it doesn't have to be, but that's the maximum, it's not below.
Does that make sense? So the maximum is 1 less than the degree, but it's not guaranteed to be that number. Okay, so those are good questions.
So that's what the equation's gonna look like?
That's a possibility.
Cause I'm just trying to see like what it's gonna look like, because I can do the graphic stuff all day, but then if you give me like a random equation and I'm like, what's the graph gonna look like without the calculator?
Right. And so that is a good point, is stuff like this talk the talk would actually be a non-calculator portion of a test. Because when I look up here, if I'm given an equation, then I should be able to pick out certain key features. For example, if I look at A, which I'm gonna tell you, this is part of your homework. If I look at A, is graph B a possibility?
No.
Why not?
It's odd.
It's an odd degree, right?
I already did this one.
That's cool.
I haven't done homework in forever and I just went ahead and.
Could it be graph C?
No.
But I thought you could have a negative.
Well, yeah, but look at the, equation.
But look at the equation.
If it was -2, then yeah, it could.
Oh, yeah.
To get this graph, A would have to be less than 0, it'd have to be a negative, and it's very clearly not a negative in that equation. So the only graph possible is A, right? Quadratic, and A is positive or greater than 0. Okay. Which of the graphs in B can we immediately eliminate? Why A?
It's possible.
Yes, that's not what I was thinking about, but yes. A. Why can we eliminate graph A?
Enough of the intercepts.
Ah, this would be a 4th degree.
Yeah.
Okay, what degree is
So that doesn't match the equation. What degree is the equation?
it?
Yeah, 5.
Five? Maybe 5.
Oh, 6. 6.
6.
3, 4, 5. No more.
Where you get 3
It's
from?
30.
It's.
Remember, the degree is the highest exponent.
Oh, yeah.
We're not multiplying here, we're adding and subtracting. If it had been like x cubed minus 3 times x squared plus 1, then when I multiply these, I would get x to the 5th and be quintic. But am I multiplying any of these terms?
No.
No. So it's just the highest degree, or the highest exponent is 3, so it'd be a cubic. Regardless, graph A is an even degree, right? So that one's out.
It's going to be graph.
Say it again.
I think it's going to be graph.
Graph B.
No, graph C. Graph C.
Why is it gotta be graph C?
Because it goes to the negative and the other one goes to the positive.
So noticing the end behavior, this would be something like y equals a positive x cubed, right? But this one would be like y equals a negative x cubed, and hey, what is my a value? Negative. And so graph C would be the closest.
I did these down here, and what I'm saying, like, you know how I did with the equation, and they were fine, but then I get to this one, and,
So you wanna look at B?
or, actually, it's A.
A is the one that gave you trouble?
I don't know, there's like, I solved 2 of them out, and I couldn't figure out why it couldn't be the first one, you know? Like, I couldn't figure out what was wrong with it, to where it couldn't be.
Like the first equation up here?
No,
Are you talking about,
I'm trying to see.
are you talking about graph A or B?
I'm trying to see, I did F2 and got that one, and I did F3 and got that one. I think it might be F1 that I was like, I don't even know what, if it's.
So you're talking about this, but you're talking about for graph A?
Yeah,
Okay.
but I
What-
circled F2, like that's what I ended up, because of the amount of X's.
I mean, could it be F1? What are y'all's thoughts?
5. No, there's 6, it's degree 6.
No, there's 5 degrees there's 5 extrema on the thing, right?
So 1, 2, 3, 4, 5 extrema, so it has to be at least degree 6. And what degree is this?
5.
5. I would have just even looked at the end behavior. The end behavior is in the same direction, so we know the degree has to be even if it's in the same direction, right? And it's an odd degree up there. So there's lots of different ways you could justify saying no for F1.
Yeah, I
Right?
think
Talking about
that's
the end behavior, talking about the degree, any of those.
No, it's not that one. I'm trying to
It
see,
can't
it's
be
one
F-
of these, but I'm not sure which one.
It can't be F3 because that's a degree of 4.
Ah, that's degree 4. This has to be degree 6, at least.
Yeah.
It could be higher,
But it needs to
but it has to be at least degree 6, because how many roots do we, or how many extrema do we have?
be
5, so the degree has to be one more.
Mhm.
Yeah. I got the
Also,
first one.
1, 2, 3, 4, 5, 6, right?
Yeah.
6 roots,
So it's gonna have.
because that's a multiplicity of 2.
So it's gonna be at least 4, 5, and below.
Well, I got 6.
For the extreme.
1, 2, 3, 4, 5, 6. Yeah.
What's your confusion, Shannon?
I was asking, it would have to be at least 5 and below for the extreme, since it's 6.
Oh, 6 degree, so it has to be extrema 5 or below. But also, we were looking at the fact that there are 5 extrema. And because there's 5 extrema, that means the degree has to be 6 or more.
I think I just got it wrong, was confused. Like, I had the answer, but I think my problem was the x, like, to the fourth, or x to the second, I was adding them together instead of thinking, like, the highest one.
Also notice, is x equals negative 2 a possible root on this graph? Maybe that one? This would be the root, x equals negative 1.5. X equals negative 0.5. Here's a double root of x equals 2.5. See how all those roots match up? So that's something to consider. Okay. So you want to go through explaining each of those. So Gracie, hopefully that helps you answer some of these. There, that number 2 there is a question you had. But remember, you already talked about it, and we discussed this. If it's a 4th degree, how many roots does it have to have? 4. But if it has only 2 real roots, then that means the other 2 are what?
Imaginary.
Imaginary.
I just don't, I just second guess it, I'm not sure that. my
But I
math
mean,
makes
and this, I'm not saying that this is a possible answer, but 1, 2, right? There's 2 real roots, right? And then 2 imaginary. Or, and this is important to recognize, which I think is what's stressing you out, is that you want to know exactly which one it is. Again, only 2 real roots, but somewhere in here there's 2 imaginary. Or, nope, that's not what I meant to do at all. 2 imaginary, right? And so there's lots of different options. You just have to have 2 real roots and 2 imaginary. You need an absolute minimum of this value, right? You need this end behavior, but again, if it's not possible to sketch, explain why. And you can get graph paper if you want to help you with that. All right. To help with all of that content, though, we are going to jump to lesson 4, function construction. This will actually help you do that homework significantly. Huh?
Which one?
This is the lesson 3 homework.
Does this make sense? Is negative minimum as x is going to positive, y is going to positive.
It's on M1-247. Grayson. Yeah.
1, 2.
Okay. So notice there's no new key terms or anything with this. This is legitimately just helping us create these quadratic, or not quadratic, these polynomial equations. So when we look at this, don't be a Rubik's Cube, or Cubic's Rube. Wow, man, I am exhausted and not feeling great.
Whoa, where's the rest of the stuff, man?
Huh?
That's
It's
it?
like,
Don't be rude.
That's all we know?
don't be a Rubik's Cube.
Don't be a, yeah. You previously built a cubic function by multiplying 3 linear functions and by multiplying a linear function and a quadratic function. Let's explore how the properties of linear and quadratic functions determine the key characteristics of cubics, right? So here is the getting started at the beginning of lesson 4. This is M1-250, I believe. Tell me if I'm lying to you.
Are you?
I don't know. Is it on M1-250?
What's wrong with being a Cubic's rube?
Cause no one wants to be a rube.
A rube? What are you gonna, what's a rube?
Let me look up what the actual definition is, but it's someone who's completely ignorant of an idea.
I'm gonna call somebody that, and I'm gonna say, but because you don't know it, that you're just,
You're such a rube.
Such a rube.
So definition for rube is a country bumpkin. I did not know that's the actual
Dang it, well,
definition.
we can't use that on anybody else. They're gonna be like, you're from Alabama, dude. Calm
Yeah.
down.
But it was
Cupid. Oh, wait, no.
Wait a minute.
apparently Grayson's a bit of a rube, but thank you for making me laugh. That made me feel much better. So the pure definition of a rube apparently is a country bumpkin, but the implication being that you're just ignorant, that you don't know. So sketch a set of functions whose product builds a cubic function with the given characteristics. Explain your reasoning. Then list similarities and differences between your graphs and your classmates' graphs. So hopefully we can actually write an equation pretty quickly for these. What is one equation that I could write here? With a 0 of x equals 0, that'd be y equals, so just put a 0 here.
I feel like it's wrong.
What's another word for a 0? A root, right? So you can think about it as x minus what? 0.
Would it be plus because it's positive too? I mean, would it be negative because it's positive too, right?
Which one?
Negative. It'd be negative because it's the opposite, right?
There you go. Remember, it's x minus r1, right? So then it'd be x
Plus 5.
plus 5. So that's one possibility. And realistically, you don't even have to do the x minus 0. It should be x times x minus 2 times x plus 5. Is that the only equation, though, that would have those factors?
No, I don't think so.
Why not?
You can do, I think you can do a quadratic formula because you got maybe,
Well, I mean, how many roots do you have?
have your three.
So it has to be what degree? 3. So it has to be a cubic, right?
Yeah.
But let me ask you this. Could I have written this equation?
Yeah, that's gonna be.
Where would you get it?
I made it up. The question I had was, can I write another equation that has those same zeros, same roots? Does this equation have these zeros still?
Yeah. Yeah. So you.
So can I change my A?
Sure. I guess.
That's what we want to see here. The bigger thing I want us to play around with is creating different equations. My point is, you can change that A to whatever you want as long as it has those zeros in this problem. Okay?
Would it change the problem?
It would change the function, yes, but would it change the roots?
No,